So we start at the beginning. It's a good place to start. And talking about energy efficiency. This entire section of 20.1 is really looking at different ways you can save energy. So you should be able to describe some of those. You don't have to know all of them, but you should be able to talk about 3 specific ways that you can use less energy. That might include more efficient machines, maybe not. So one example is LEDs versus incandescents. LED stands for light emitting diodes. So that's just a type of light. It's like halogens or neon lights. And that's something that people are switching over to because incandescents are no longer manufactured. So incandescents lost like 90% of their energy to heat. So incandescent light bulbs got really, really hot. Light emitting diodes are much more efficient, so they lose less energy to heat, which means they use less electricity overall, which is why using them is really helpful. The easiest way, though, this is something that you should know, the easiest way to conserve energy is just to use less. So implementing small changes that cause you to use less energy, like turning the lights off when you're not in the room, or unplugging appliances when they're not in use, or using less water. For example, you can turn off the water when you're brushing your teeth instead of leaving it on the whole time. Take shorter showers. Take showers that are a little bit colder. Some of those are things that are easy to implement for some people, and others are like, nope, I need a hot shower or I'm a terrible grump, just like some people need coffee or they're a terrible grump. So there are lots of things that people can do. One thing you want to be aware of is if a question asks about an economic benefit, then that's looking at monetarily how can something be beneficial, or how would it be a disadvantage, versus environmental benefit. And then if you're talking about environmental benefit, you can't just say use less electricity. You have to say use less electricity, which therefore means you're burning less coal, which means you're releasing less air pollutants. So you have to be really specific in that. Okay. Looking at the next page, some of the terms you want to know are negawatts. Negawatts is the idea is it's like the energy that you save. So it's negative energy use. And some policies are looking at maybe giving people credit for the megawatts that they have or produce, so they can trade those or cash them in. Green building. If you are able to build a new house, there's a ton of things you can do to have a building that is economically, environmentally friendly. And most of the things will pay for themselves after 5 or 10, maybe 20 years at the most. So you should know specifically from green buildings at least 3 different ways or ideas that you can have a green building, things that you can do to make a building greener. This is related to passive housing standards. So the passive housing standards are just energy use limits. So the house can only use so much or produce so much energy or so much CO2 waste. And this is something that as new housing standards come along and people build new housing, that the construction companies have to meet, so that by a certain date, however many years into the future, all buildings should theoretically meet a certain energy requirement or energy limit. Okay. This picture is kind of interesting. It shows where heat gets lost from in a house. So there's a lot of heat stored in houses because of how they're designed. So some things will build up heat and then release them slowly. Houses tend to do that. These are all examples of passive housing, things that can be implemented. So you can plant trees to cut your cooling cost. You can put in better weather stripping and install windows that are, rather than 1 pane of glass thick, that are 2 or 3 panes of glass thick. That helps with cooling and heating costs. You could install or build geothermal access for heating and cooling. So that means that in the summer your house would get cooled, and in the winter your house would be warmed a little bit using that geothermal energy. These are just some of the examples of things that you could give as examples for green building standards. One other really simple fix for being more efficient is in transportation. So this is choosing to purchase a different car, perhaps, that has better fuel mileage, so that you burn less gas and you can still drive farther. Maybe getting a hydroelectric car or a completely electric car. Obviously, that doesn't work for everybody. If you have to drive across the country, you can't just get an electric car because you're not going to be able to charge it all the time. So there are limitations to some of that technology. And infrastructure, economically speaking, would be really expensive to build charging stations across the country. Lucas?
What's the difference between an electric car and a just normal gas car, because they both use different fossil fuels, essentially?
Correct. The idea is the transfer of energy and how efficient that is. So when you burn coal and you use electricity through that, I don't know what the difference in efficiency is, but that has a certain percentage efficiency versus charging your car battery for an electric car, and then using that electric energy to run your motor. That has a different percentage of efficiency. Also, as we move towards the electricity that comes from outlets and that you get from your homes and for businesses, as we move to that being more renewable based and more sustainable, then anybody charging their vehicles using that electricity is also moving their use of fossil fuels to renewable sources. That makes sense. But that is a fair question. What does it matter if you're still burning fossil fuels at the end? Okay. Another thing that people could do is carpool. Not a lot of people do that, or use mass transit, public transit. Again, that's difficult because we don't necessarily have good public transportation systems, especially in the middle of nowhere, Indiana, which we kind of are close to the middle of nowhere, Indiana. If you haven't noticed, there's a lot of corn around Marion, lots of farms. But those are some ideas for making transportation more efficient. Okay, this is an example of a case study looking at New York's goal. So you can read that. This page talks about auto efficiency. So you should kind of briefly know some of the background of how auto industry has contributed to the efficiency of their cars. Most of the time, the reason that an industry makes a change is not because they voluntarily do it. It's because a law was passed that requires them to do it. So that is actually what happened. In the 1970s, there was some problems with the price of oil, so gas mileage increased quite a bit because oil got much more expensive. So there was pressure on the auto industry to increase the gas mileage so people wouldn't have to use as much gas. But then when fuel prices dropped in the 1990s, that's a good decade, it's because I was born in that decade, then the auto industry didn't increase gas mileage really. It just kind of was stagnant. There were no improvements in that area. But when another law got passed in 2012, this regulation says that all vehicles have to be able, not all vehicles, all light trucks and cars have to have an average of 54.5 miles per gallon by 2025. That's not very far away from right now. And if you see any ads for new cars, you know that a lot of cars are much more efficient in how they use gas and how much gas they need in order to function. So if you buy a brand new car, like a Prius is a good example of that, you could get 50 miles to the gallon. Ethan?
Like my car, when I stop at a stop sign,
Yeah.
a red light, it turns off.
That's cool.
So that way it saves me gas.
Yeah, that's true. What kind of car is it?
Terrain.
Okay, good to know. Didn't know that was one of the things, but that's a good example of something that vehicle manufacturers have included to help save on gas and make the cars more energy efficient. Cogeneration, this is not a terribly new idea, but it is gaining a lot of popularity. It's the idea that you have a combined heat and power plant. So the power plant, or the place where electricity would be generated for a system, is going to produce a lot of extra heat, because heat is one of the things that the energy is wasted as. So if it's not 100% efficient, some of it's converted to heat. So that heat can be captured and used to distribute hot water or steam. So this is really good for places like colleges that have centralized dorms and shower facilities. So you use the heat generated from producing electricity and capture that extra heat to also heat your water. Okay, so the cogeneration is a idea that's taking off. Smart metering is another thing that some utility companies are getting behind. It's electrical meters, or units that record data, and they record it very quickly. So it's like every hour. And then that smart meter reads back to and talks to the utility company so that if there's extra energy, or if a person's not using energy during a time when a bunch of other people are, they can benefit from that. So smart metering is something that utility companies have to get behind because they usually have to install the meters, but it can help people balance who uses energy when. So if you're going to run your dishwasher, you can run your dishwasher in the middle of the night when people aren't using a bunch of electricity, and that's better for the system and the power grid. And that's the idea of what a smart meter allows people to do. This particular box, the what can you do, these are steps you can take to save energy. You should be able to give a couple of examples from this. This is, again, just what are things you can do to be more efficient or use less energy. But you should know the difference between an economic benefit and an environmental benefit. So why would joining a carpool be better for the economy? Not just why does it make things cheaper for you. Yeah, that's probably because somebody was goofing off yesterday with the staples. Hopefully that one is not stapled though. Okay, will you throw the other one out for me? Thanks. Solar energy. This is exactly what it sounds like. It's energy from the sun. So there are two basic systems for solar energy. There's active and passive solar systems. Passive heat absorption or passive solar systems don't have any moving parts. Active solar systems have moving parts. So people don't usually think of a stone building as being a passive heat system or a passive solar system, but it is because the stone absorbs energy throughout the day and then it releases it really slowly at night. So adobe huts that would be made out of mud, those would be passive heat systems as well because they would absorb the heat throughout the day and then slowly release it at night. Some active solar systems, this is what people normally think of when they think like solar power, so photovoltaic cells, or CSPs, which are concentrating solar power plants, or solar power systems. You'd want to know kind of what that looks like. So the basic design of CSPs is actually explained right here, but there's a picture of it on the next page, so that helps. Essentially, you have really long U-shaped or parabolic shaped mirrors that help focus the sun on a heating tower. And the mirrors turn or rotate to follow the path of the sun throughout the day. Another good thing about this design is they're normally placed in deserts or places where there's a possibility for violent storms and lots of sand. So the mirrors can turn and rotate and point down when there's a storm predicted so that they don't get damaged. So it's not like you have to fix the mirrors every single time there's a dust storm. The system's designed to protect the mirrors. So an advantage of CSPs is that we could build enough of those to probably power most of the world. The disadvantage is that because they usually have to be placed in the desert, because that's where the most intense sun tends to be, that can harm the desert ecosystem. And desert ecosystem is biologically rich. It's also vulnerable. It takes a long time to recover from any invasion or damage. So a lot of biologists and wildlife conservationists are concerned about people just building solar power plants like these mirrors, like the CSPs in the Saharan desert, for example. There was a plan at one point for Europe to build really big plants in the Saharan desert and then transfer the electricity to Europe to power Europe. That did not happen, and I don't know that that will happen. There's a lot of political reasons for people to be upset by that. But those are some advantages and disadvantages of CSPs. Photovoltaic cells. Okay, sometimes they're abbreviated PV cells. This is an example of how they work. So the sun hits a top layer that has sometimes it's called the N-type layer, but that layer, then the electrons are excited and they're forced to pass through to the bottom layer. So it's a one-way barrier that the electrons pass through. And then there's a charge difference because the electrons have transferred. So the wires that connect the top layer and the bottom layer allow the electricity to move through that and to even out the charge, and then you generate electricity because of that. So the moving electrons generate an electrical current. Okay. That's the basic design of PV cells. Right here, it talks about the relationship between kind of cost and supply. So solar power used to be pretty expensive. As it became more available, it got cheaper. This is just kind of like a basic economics thing, but it does play into renewable energy because as renewable energy becomes more available, it should get cheaper. That's a good thing, at least for people who want to use renewable energy. Not such a good thing for oil companies and coal companies. So, talking about economics, there you go. Okay. Questions about anything so far? Okay. Let's look at these. I don't have a post-it note on this page because I've got something noted on the other page. You should, in general, know what PACE is. It's an example. It is an example of how energy can be promoted, specifically renewable energy can be promoted. So this uses city bonds, which is a type of loan, sort of, to pay for renewable energy and conservation expenses. So people can use the bond and then pay it off slowly. So like I said, it's kind of like a type of loan. If I got that wrong, I'm sorry. I'm not an economics person, so my understanding is a bond is kind of like a loan. Some other things in photovoltaic technology is the change in what you have to use in order to get that energy. So you used to have to use really thin sheets of crystal, and now they're able to make conductors out of silicon, so it's cheaper to make the materials for PV cells, and that's been a good improvement. There are several examples throughout the book of public policies that help promote energy. You should be able to describe 2 of them. I don't care which 2. The only reason you would need to use 2 is if you get a free response question that says, talk about a policy to promote renewable energy. You should be able to talk about at least 1. I would say 2 in case you forget about 1 in the heat of the moment, and then hopefully you're good to go. Obviously, the more that you remember, though, the better off you are. So try to remember at least 2. A really simple one is called feed-in tariff. So if I, as a homeowner, install solar panels on my house, and then I produce extra electricity, a feed-in tariff requires the utility company to buy the electricity from me at a fair price. Utility companies are not always in favor of that because they don't make the electricity for people, so they're losing money because people aren't paying them for electricity, and then they have to pay money if people make extra electricity beyond what they need. So there's some reasons why people might not want a policy like that. Some other policies include allowing utility companies to charge more if the energy comes from a renewable resource. So that's an incentive for the utility company to invest in renewable energy because they can charge more, so they can help offset that cost. The consumers might not be very fond of that. So every policy has its advantages and disadvantages for who it benefits most. Okay. And these are some examples of how solar panels can be used, or where they can be used. Okay. Wind energy. Watt versus hot. So vertical versus horizontal. That's pretty much the difference. So this is an example of I'm going to say it wrong, of a hot. So it's a horizontal axis. So that means that the blades spin on a horizontal axis. This is a vertical axis wind turbine. So they spin vertically, so this way. Okay. The advantage of a vertical axis turbine versus a horizontal axis turbine is that it takes up less room. So you don't have to space things out quite as far, and that can be helpful. They also don't necessarily require as much wind speed or energy in order to power, so you can use them in places where you might not be able to use a hot. So wind energy could meet all of our needs, but there are advantages and disadvantages to it. One of the limitations is that it's not constant, so wind is not consistent. So if you don't have any wind energy, you either have to have enough electricity stored to tide you over until the wind picks up again, or you have to have another source of energy. That is one major disadvantage. Not every place has strong enough wind either. So this is a map in general of where wind speed is good enough, or what wind speed looks like overall. So right in here, so the Great Plains, and then along the shorelines, east and west coast, and in the Great Lakes, that's pretty much where you can put wind turbines and be the most successful. There are wind turbines in other places, but that's where you'll get the most energy most consistently. Okay. there are different ways that people finance stuff like this. So sometimes they work together to build a wind farm, and then everybody in the area profits from that. So it's called a cooperative. Some people, another disadvantage of wind farms is people are worried about bird and bat mortalities. So how many birds and bats die because they run into the turbines. One thing to keep in mind is that more wildlife is killed by non-renewable energy sources and accidents than by renewable energy sources. So yes, it's sad that birds run into the blades and die, but there are things you can do, like not put the wind turbines in the place where birds migrate. So don't put them in a migratory path. That'll help minimize accidents. But also, you have to keep in mind how many animals die because of things like oil spills or air pollution and stuff like that as well. So it's a balancing act. The basic design of fuel cells is talked about on the next page, but a fuel cell produces fuel chemically. So there's a chemical reaction that occurs. This is not a new idea. This idea goes all the way back to 1839. So it's old compared to some of the other types of energy and some of the other technologies. But in general, a fuel cell will work as long as you have access to hydrogen and oxygen. So you have to have access to both of those, okay? And this figure talks about the general design for that. Biomass, that's using anything that's organic. So plants, manure is biomass technically. And that's a source of fuel people have been using for a really long time. One disadvantage of that is that in developing countries, if people use dung or animal manure as a fuel source for their fires, for cooking fires, they run out of that manure to put onto their crops so that they can have fertilizer. So if you use all the animal dung for fuel instead of using it as fertilizer, then you start to have energy or nutritional deficient crops. Yeah.
Bird methane.
So yeah, it's kind of the same idea as capturing methane to burn. And that's something that's talked about in here too. So methane can be clean and efficient. A lot of methane, we talked about this in the last chapter, gets burned off just as extra energy that the companies don't want. But methane is also produced by landfills and by organic waste. So some places in, I don't think it's India, I think it's China, use a methane kind of trapper. They put food waste and stuff into it, and then as it composts, it collects the methane, and then that methane is used to heat the house or produce fire for cooking with. So you can capture that methane and use it to heat a home, or maybe several homes, depending on how much food waste we're talking about. Okay. There are some other places, like colleges, that are starting to use this idea of a biofuel digester or a biogas collector to produce heat and electricity for themselves instead of just relying on the fossil fuels and the utility grid. Okay. So this is kind of an example of what that looks like. Okay, how are we doing so far? Okay. Biofuels versus cellulosic ethanol. The difference is pretty much where you get the organic material from. So biofuels are fuels that are produced from something that's organic. Ethanol specifically usually comes from corn. And in the process of creating the ethanol to burn, you have to ferment everything so it converts the sugar to alcohol. Then you have to distill it and get rid of the byproducts, that all you have left is the ethanol. And yes, before you ask, you could drink the ethanol, but they add something to the ethanol so that nobody would want to drink it. So before that denaturant's added, though, there you go, you can have alcohol. Okay. I figured I'd mention that because I thought somebody might ask or might be curious, so there you go. Cellulosic ethanol would be ethanol produced from woody plants instead of just herbaceous plants.